Positioning a ladder. I'm going to do 56. Ladder from exercise 55. So that ladder is 18 feet and it's resting against the wall of the building. The ladder is 7 feet from the base of the wall on 56. How high up the wall will the ladder reach? So let me draw a picture. This is my wall, so that's how I'm going to know the height. This is my ladder, that hypotenuse, which is 18 feet. And the ladder is 7 feet from the base of the wall. No trig involved in here. This is just a squared plus b squared equals c squared. So 18 squared is equal to my height squared plus 7 squared. So 18 squared minus 7 squared is equal to my height squared. So I want the square root of that. Pick up your calculator and put in the square root of 18 squared minus 7 squared. And you can do it all in one. You don't have to do 18 squared minus 7 squared and then take the square root. Do it all in once in these calculators easily. And you get approximately 16.583. And it's in feet. So this was feet. This was feet. Next one, 57 and 58. Here's what we're using here. There's a vertical rise and there's a slope length. So make sure you know what they're talking about. Find the vertical rise to the nearest foot. So this is what I want to find. So that's my x. With a slope length. So the slope length here is 2,050 feet, assuming that the angle formed by the horizontal line at the top of the terminal and the lift cable is 16 degrees. So notice I have an opposite side from 16 that I want to find, and I have a hypotenuse that I know. Sine is a trig function that uses opposite and hypotenuse. So the sine of 16 degrees is equal to my opposite over my hypotenuse. So my x is equal to 2,050 times the sine of 16 degrees. Before you put this in your calculator, check your calculator. Make sure that the mode is in degrees and not radians, because if it's in radians, you will get the wrong answer. And then pick up your calculator and put in 2,050 sine 16, and you will get approximately 565.06 feet. So that's the height, the vertical lift. 60, a shadow length. At the time when the sun's rays makes a 60-degree angle with a horizontal, how long is the shadow cast by a 6-foot man standing on the background? So here's a man, he's 6 feet tall. And there's a shadow there. And I don't know how tall that is. That's what I want to know. And it says, at the time when the sun's rays make a 60-degree angle with the horizontal, so that's 60, or if you want to look at it this way, that's 60. So that's my x I want to find. When I do this, opposite side, adjacent side, so that would be tangent. So the tangent of 60 degrees is equal to my opposite over my adjacent. So x is equal to 6 divided by the tangent of 60 degrees. And before you do that, I wouldn't pick up your calculator and do this one. If I were doing this one, I would have put this in my calculator, or I would have used one of the triangles that I know, which is a 1, 2, radical 3 triangle. So when you do that, tangent of 60 is radical 3 over 1, or just radical 3. So then I have 6 over radical 3 rationalize the denominator, and you have 6 radical 3 over 3, which reduces to 2 radical 3. And it is in feet. And on a test, you would be done right there. Height of a cliff. The angle of elevation from a rowboat moored 75 feet from a cliff is 60 degrees. Find the height of the cliff. So I have a cliff here. The angle of elevation from a rowboat moored 75 feet from a cliff. So there's 75 feet from the cliff. The angle of elevation, so my rowboat's right here. So this angle right here is 60 degrees. Find the height of the cliff. There's my x. Again, opposite and adjacent. So tangent of 60 degrees is equal to opposite over adjacent. So x is equal to 75 tangent of 60. Tangent of 60, and if you need to draw it out again, draw your triangle out. 1, 2, radical 3. So tangent, that's radical 3. Tangent is radical 3 over 1 or radical 3. So the height of the cliff is 75 radical 3, and I was in feet. Flying a kite. A girl is holding a kite string at a height of 5 feet. So there's a girl 5 feet tall. How long must the string be? So there's my string. So there's my picture of it. So this is 5 feet. So how long must the string be for her to raise this 200 feet? So this right here is 200 feet. So this length right here is 195. 200 minus the 5. And it says the angle of elevation it makes to the ground is 30 degrees. So I want to know how long is my string. I have an opposite side that I know. I have a hypotenuse I want to find. That is sine. So the sine of 30 degrees is equal to opposite over hypotenuse. Let me draw my triangle. If this were a 30-degree triangle, this would be 1, 2, radical 3. So the sine is 1/2. So if I were solving this, it would be 1/2 is equal to 195 over x. Cross multiply. X is equal to 195 times 2, which is 390, and I'm in feet. 68. Sighting a mortar station. The angle of depression from a helicopter 3,000 feet directly above an Allied mortar station to an enemy supply depot is 13 degrees. How far is the depot from the mortar station? Okay, so I have a helicopter. 3,000 feet. The angle of depression from a helicopter to an Allied mortar station to an enemy depot. So there's my enemy depot. Okay. So there's my picture. I have 3,000 feet is my height. My right triangle. I have my angle of depression right there, which is 13 degrees. So this angle also is 13 degrees. How far is the depot from the mortar station? So they want to know this right here. Okay. So here was my mortar station, the LA mortar station. Right over here was my enemy supply. They want to know that distance there. Angle that I know, 13 degrees. Opposite side that I know, 3,000 feet. An adjacent side I want to find, so I need to know tangent, or use tangent. So the tangent of 13 degrees is equal to the opposite over the adjacent. Solve for x, and you'll have x is equal to 3,000 over tangent of 13 degrees. And then now pick up your calculator. I would not pick up your calculator until you write down what you're supposed to do, because I find when people use this right here, sometimes by accident they'll put in tangent of 13 over 3,000, or they'll do it incorrectly. So I would write it out correctly the first time, and then when you do that, you'll get 1,2,994, 12,994 feet. Or if you want to do more decimal places, it was 0.42762. 70. Spotting a spotlight. A spotlight will be set in the ground so that the beam makes a 40-degree angle with the ground. If the light is to hit a spot 7 feet above the ground on a vertical wall, okay, so I have a vertical wall here, a right angle, it's 7 feet. A spotlight was set in the ground, so my spotlight will be over here at this corner. The beam makes a 40-degree angle, so there's a 40 degrees, 40 degrees. How far from the wall? X is what I want to find. So again, opposite and adjacent is tangent. So the tangent of 40 degrees is equal to opposite over adjacent. So X is equal to 7 over the tangent of 40 degrees. So pick up your calculator, and then in your calculator, you would put 7 divided by tangent of 40, and you'll get approximately 8.34, and I'm in feet. Mooring a boat. A boat is attached at water level by a taut line to a dock that is 4 feet above water level. The angle of depression from the dock to the boat is 14 degrees. How long is the rope? Okay, so I have a line that is attached, and it says at water level. The dock is 4 feet above water level. The angle of depression from the dock to the boat, so that angle right there, which is the same as that angle right there, is 14 degrees. How long is the rope? There's my X. Again, tangent. Tangent of 14 degrees is equal to the opposite over the adjacent side. So I would take that and I would solve it before you put it in your calculator. So I would write X is equal to 4 over the tangent of 14 degrees. Pick up your calculator, put it in your calculator, and you get 16 point. Let's see, a boat is attached at water level by a taut line to a dock. Whoops, that's not right. The line is on the dock, it's not at the low water level. So this is not right. So let me erase it and draw my picture again. If I could read properly, I'd get the right answer. I'm 4 feet above, and here's where my line is. It's attached to the dock that's 4 feet above the water level. 14 degrees. There's my X. And so now it's not a tangent function. Opposite and hypotenuse, it's sine. So the sine of 14 degrees is equal to my opposite over my hypotenuse. So now, if you put it in your calculator, you should get the right answer. And when you put it in, you'll get, solve it first before I put it in, so I don't make a mistake putting it in. So 4 divided by sine of 14 degrees. So when you put it in your calculator, you get 16.53, which they said round to the nearest foot. So therefore it's 17 feet. So there's my line. The line's not at water level to the dock. The line is up above onto the dock. 74. Find the radius of the 50th parallel of latitude. Okay, when I'm doing this, I have the Earth here, and there's the equator, and I'm somewhere up here, so I'm just drawing it right there. So when I do that, that angle, if it's the 50th parallel, is 50 degrees. So this angle here is 50 degrees. Let me keep drawing my picture here. I have a right triangle now. This right here is the radius of the Earth. The blue line is the radius that you have at the 50th parallel. So now let's look what we have here. I have an angle, I have a side adjacent that I want to find, and I have a hypotenuse that I know. So you should say to yourself, what trig function uses adjacent or hypotenuse? And I hope you say cosine. So the cosine of 50 degrees is equal to, call that x. X is the radius at the 50th parallel. So adjacent over hypotenuse. So when you're doing this, pick up your calculator. You can solve it first. Cosine of 50, plug it in my calculator. So when I put in my calculator 3,960 cosine of 50 degrees, I get 2,545 miles. I'm going to stop here with this video. I'm going to have a part 3 video with a few more problems.